Here we go. We have a question, minimize the height part 1. So you have given a positive integer k and an array denoting height of towers. You have to modify the height of each tower either by increasing or by decreasing them by k units only once. And we need to find out what could be the possible minimum difference of the height of the shortest and the longest tower after you have modified each tower. So here is an example. So let's suppose we will increment each and every element by k. So one difference can be maximum minus minimum, or the last value minus the first value after sorting the array. Then we need to find out the minimum difference after modifying the array. Either we can increment or we can decrement a element. So if I increment this element and decrement this and this, so the maximum is 8, minimum is 3, so we got 5. And we have this example. If I increment this then decrement this and this, so we got 11. So as you can see, after a certain point all the elements get decreased by k, and before that all the elements increased by k. So let's try to build the approach. There's a slight hint that I have just given you. So first of all, we have to sort the array, so it will be easier for us to find the minimum difference. So let's first sort the array. So we got 1, then we got 2, then we got 3 only once, then we got 4, then we got 5, then we got 7, then we got 8, 7 8, then 2 times 9 9 9, and 1 times 10. So let's suppose we increment each and every element by k. And one more thing is, the height can be negative. The height can be negative values, although it does not make any sense, but in the test cases it is given that heights can be negative. So here you can see the height cannot be negative, but after I submitted the solution, I got stuck, and in the test case the height is negative, so we have to take care of this value. So here is the proof. In the example, my solution failed on test case 2. In this, the height is negative, although it does not make any sense. And here it is also given height is positive, but GFG, I don't know why, is added height negative test case in the test cases. So let's try to build the approach and let's continue. So after that, we have to first increment all the values till a certain point, and after that all the elements get decreased by k. So let's first find out. So first of all, what we got is, we have to find out we will start at this position. So we will start at this position. In this position we will first, till here what I will do is, I will increment, and after that I will decrement all the values. So this element increase and this element decrease, and all the elements get decreased. This element increases. So let's try to find out. We will start at position 1. And what we'll do is, we increment all the values. This is the ith value, and from ith till n minus 1 I will increment all the values. From I till the last value I will increment all the values. We don't need to increment, um, we just need to find out the value. So if I increment this value, sorry, just made a mistake. uh, Till from 0 to I minus 1, from 0 to I minus 1 I will I will increment, and from I till n minus 1 we have to decrement all the values. So we have to decrement all the values. So what will be the maximum value? So let's take let's take I position as any random position. So let's take this position. This is our I position, and this is our I position. From here to here I will decrement, and from here to here I will increment. I will increment. So what will be the minimum value? I am I am decrementing this. I am decrementing this. So either it will be array of I minus k. Either this will be my this will be my minimum value, or this will be my minimum value. Means array of 0 plus k. Either this will be my minimum value, or this will be my minimum value. So let me circle this. So this will be my minimum value. So this is this, or this is my minimum value. So this is minimum. And what about maximum? So either this will be my maximum value. What I mean is array of n minus 1 minus k. Either this will be my maximum value, or array of I minus 1 plus k, or this will be my maximum value. So one is this and this. So after iterating from all the values, we have maximum and minimum. We don't need to find exactly maximum or minimum. So we don't need to increment each and every value from I till n minus 1, and increment all the values from 0 to I minus 1. We don't need to do this. We just need to find out our maximum or our minimum. So answer can be maximum minus minimum, and already stored answer. We need to find out minimum answer. So let's take minimum. So from iterating this, we can easily find out. So let's um, apply this algorithm on our test case. We have 3, 9, 12, 16 and 20. I think it is 16. Yes. So I will increment all the values till here and decrement all the values till here. What will be my minimum value? So either this minus k. Here k is 3. K is 3. So what will be my minimum value? So this value minus 3 is equal to 6. Either 6 or 0th plus k. 0th plus k 6. So either this will be my minimum value, and let's find out our maximum value. What will be the maximum value? The maximum value is last minus 3. So it will be 17, or this plus 3. So it will be 6. So our maximum is 17 minus 6. 17 minus 6 is 11. So our answer can be 11. Or our answer, if I increment all the values, so this will be incremented. So last value minus first value, so it will be 17. So let's iterate from here to here. So in this case, what will be our minimum value? So this minus k will be 9, or 0 plus k. So this plus 3 is equal to 6 itself, and last minus k will be 17. This last minus 17, or yes, then we have this value plus k, so it will be 12. So our maximum is 17, and we have minimum as 6. So so same applies here. We got maximum as 17, and we have 6. So 17 minus 6 is 11. And all different, you can try for all different variations, but the minimum answer is 11. As you can see, the minimum answer is 11. So let's code this. First we have to sort this, then we have n, and this will be our initial answer. Then we need to return the answer and start from index 1, and from 0 to I minus 1 we will increment, from I to n minus 1 we will decrement. So before decrement we need to check if it is still positive. So this condition does not apply here, but this condition applies in the slight modification. So you can find the problem here. So this condition applies there but not here, and both the problems is exactly the same. Then we need to find out minimum, and then we need to find out maximum, and then just we need to find out our minimum answer. So let's give it a try, and let's talk about time and space complexity. So in this function we are sorting our input array. So the answer, so the time complexity is n log n, space complexity is constant. And thank you all for watching.